Alright folks, welcome back. In this video we're going to talk about a very important topic when it comes to hypothesis testing, and that is, well, establishing those hypotheses, right? How do we determine what is our null hypothesis, what is our alternative hypothesis, and then, more importantly, which of those is the claim? We're going to give 3 examples right now to go over that very principle. So, first of all, let's look at this. Scientists report that the average life expectancy for a specific type of frog is no more than 7 years, and determine the null and alternative hypotheses and note which is the claim. Okay, so that is the problem here. This is a fairly standard problem that you'll be seeing when it comes to hypothesis testing. Identify the null and alternative hypotheses and then determine the claim. Now there's a few things to point out in the problem itself. Notice that this is all talking about things with respect to the average, okay? That's what these hypotheses are done with respect to, right? They're calculated with respect to the average, okay? Now that's the first bit. We need to determine what we're talking about, the average. Now also we need to identify, well, what's the claim that's sort of being made in the statement itself? And that comes right about here, wherever the numbers basically occur. No more than 7 years. No more than 7 years. What does that mean? All right, let's think about what that means before we even identify what hypotheses we're talking about. What does this statement mean? What we're saying is the average, which we're going to represent with this Greek letter mu, is no more than 7. Does that mean it could be 7? Sure. It just can't be 8 or 9 or 10 or 7.1 or 7.001. It can't be any bigger than 7. But it can be 7, 6, 5, 4, 3, 2, all the numbers in between. So that means that the average we are saying is less than or equal to 7. This is our claim. The claim is that the average life expectancy is less than or equal to 7. With that, let's build our null and alternative hypotheses. So the null hypothesis we represent with h sub 0, and the alternative hypothesis we represent with h sub a. Now, the null hypothesis, remember, the null hypothesis always contains equality. It always contains equality. So, we happen to have an equality statement right here, right? Less than or equal to. Right? So we're building the hypotheses with respect to the mean using the numbers that are given to us in the problem. So we're making statements, we're making hypotheses about the average. So the null hypothesis would be that the average is less than or equal to 7. The alternative hypothesis is the complement of that, meaning the opposite, so to speak. That if I'm saying that the null hypothesis is less than or equal to, the alternative hypothesis should be the opposite of that, or greater than, right? Less than and greater than are opposites, less than or equal to and greater than are opposites, and greater than or equal to and less than are opposites, okay? So if I'm saying the mean is less than or equal to 7 in the null hypothesis, and the alternative hypothesis, I would say that the mean is greater than 7, right? The opposite of what the alternative hypothesis is saying. Now, the last part of this question was, what is the claim? Well, we kind of already have done that, right? We wrote out the claim that was given to us in the problem, so now we just need to determine which of these hypotheses match our claim. Well, that's going to be my null hypothesis. So the null hypothesis, that the mean is less than or equal to 7, that is our claim. All right, let's move on to another type of problem here. Here we have a credit card company claims that the average time it takes to process transactions is less than 7.25 minutes. Determine the null and alternative hypotheses and note which is the claim. Okay, so the problem statement at the end, the task that we are given is the same. Determine the null and alternative hypotheses and then note which one is the claim. But the first part has some slightly different information in there. Once again, we're talking about things with respect to the average, but also we need to determine what the actual numbers are here. That the average time is less than 7.25 minutes. So what our claim is in this problem is that the average, which is our mean, is less than 7.25 minutes. That is the claim being made in this problem. So, when we're asked to create the null and alternative hypotheses, we know that one of them is going to contain this statement right here. And we know that the other is going to be the complement of that. Now, which of these hypotheses would be this? Which of these hypotheses would be that the mean is less than 7.25? Well, remember, the null always contains equality. Does this statement contain equality? No, right? It's strictly less than. It is strictly less than, which means that this statement, the mean being less than 7.25, is our alternative hypothesis. So our alternative hypothesis is the mean is less than 7.25, and the null hypothesis is going to be the complement of that, or the opposite of that. So if we're talking about less than in the alternative, we're going to be talking about greater than or equal to in the null. So the mean is greater than or equal to 7.25 is our null hypothesis. And this makes sense because we have equality in our null hypothesis, right? Greater than or equal to, okay? So now the last part of the question is, which of these is the claim? Well, once again, we've already established that, right? The alternative hypothesis is our claim because the alternative hypothesis matches the statement that's in the problem. One more problem to go through here, one more type of problem that you'll see. A local baseball team claims the average attendance at last week's games was exactly 23,333. Determine the null and alternative hypotheses and note which is the claim. Okay, once again, that last statement is standard, but we need to determine, again, we're talking with respect to the average and also the numbers, right? We're saying exactly, it is exactly 23,333. Some statistician behind the scenes was crunching the numbers, and this is what they claim to have found. Okay, so what is the claim? What is the claim that's being made in this problem statement? Very clearly, the mean is equal to 23,333. That is the claim being made in this problem. So let's establish our null and alternative hypotheses, okay? Now, which of these alternative or null hypotheses, which of these hypotheses is going to contain this statement, the mean is equal to 23,333? We know that the null contains equality, and sure enough, this is equality, right? The mean being equal to 23,333. So we would say that our mean is equal to 23,333. That is our our null hypothesis because it contains equality. The mean equals 23,333 is our null hypothesis. The alternative hypothesis is going to be the complement of that, or the opposite of that. Well, what's the opposite of equality? Well, inequality, or not equality. So we would say that the mean is not equal to 23,333. So that means it could be greater than, or it could be less than. So you might see that every once in a while. You might see instead of it being a strict not equality, it might be like a less than, or it might be a greater than. But for this, we're going to put an not equal to symbol in there. So the null is that the mean is equal to 23,000 and change, and the alternative is that the mean is not equal to 23,000 and change. Now, lastly, which of these is the claim? Well, as we've said, the null hypothesis matches the claim statement from the problem. So this is how we establish our hypotheses for hypothesis testing. Remember that the null always contains equality, and the alternative is always the complement, or the opposite, of that null hypothesis. Okay? So check back in for more examples, guys. I'll see you next time.